So somebody has already started the recording. If you have done, just I don't know, means you can just stop recording. I will start it again. Any one of you, if you have started recording, just stop it. I will start it again. I don't know. Okay, if you will get the recording, it's fine. If you will not, okay. So I will share the slide. Can you see the slide?
Yes, ma'am.
Okay. So let's start from here. Okay, now we know that there are various sources of air pollution, including the industries where you will find both fugitive emission, that means the emission which is coming out from the process and it's a area sprayed emissions, and also the emissions from stacks, right? Um, so when we would like to know what is the emission rate from a stack and what would be the concentration of any pollutant downwind in downwind direction, say XYZ distance from the stack, then either we have to do the monitoring at that XYZ places. That is one way. The other way is after knowing the emission rate, that means the gram of pollutant emitted. We can also use the dispersion models to estimate the concentration of any pollutant at any downwind distance. Now, having said that, we we need to know how this dispersion model works. Before that, we just go through some of the. Okay, mute all your mics. Please mute your mics. Please mute your mics. So, what are the factors that affects the dispersion of the pollutant? So, first thing, as I said, the source would be the major factor, because the source which is polluting or which is emitting the various pollutants in the atmosphere, its characteristics is highly important to understand what kind of emissions are there, what is the quantity of each pollutant emitted by the source, and like it's a what is the velocity through which the emission is emitted in the atmosphere, and so on. So here I'm just trying to explain you the source characteristics which are important for understanding the dispersion of the pollutant in the atmosphere. So industrial plume discharge vertical through a duct or the stack. So the duct or the stack, they emit the emissions vertically in the atmosphere, and then because of the horizontal wind speed, the plume bends towards the ground. Okay, so then after leaving the stack, the plume tends to expand and mix in with the ambient air. At the same time, while this dilution and dispersion is taking place, the horizontal air or horizontal velocity of wind, because of that this plume will try to bend towards the ground, and the ground level concentration will also increase. Whether even if the emission or the stack is 200-meter high, there would be some point where the ground level concentration will be affected by the emissions coming out from the stack. Horizontal air will tend to bend. This is what I have explained just now. The plume rise is affected by both upward inertia and of discharge gas stream and by its buoyancy. Upward inertia of discharge gas stream or flue gas is actually because of the velocity of the flue gas which is coming out from the stack, and whatever is the mass that governs the inertia of the plume coming out from the stack. And then its buoyancy. Buoyancy means uh, the difference in density of the plume which is coming out from the stack and the surrounding air. Okay, so that will put another force on plume, which is the drag force. So this two factor will also affect the dispersion of the plume, and these factor, which is like velocity and density of the plume, that depends upon the characteristics of the source. For example, for like power plant where the combustion temperature is very high, the velocity of the flue gas will be higher than another source, say brick kiln, where there is also stack is there, but the combustion temperature is relatively lower than the power plant. So what will happen, because of the low combustion temperature, the and probably high moisture content, um, the velocity, the density of the plume which is coming out from the brick kiln would be very different than the one which is coming out from the power plant. Okay, so that the source characteristics, the combustion process, or you can say the type of fuel which is being used in the source, all that will affect the final flue gas composition, its thermal characteristics, therefore its dispersion and dilution in the atmosphere. Is that clear? Is there any question in this part? Okay, so let's go ahead. So atmospheric dispersion will be affected by increasing the exit gas velocity, and the exit gas or the flue gas, you can say, temperature will increase the plume rise. So there would be a vertical rise of the plume when the plume go out from the stack, right? That vertical rise will increase with the increase in flue gas velocity and the gas temperature. The plume rise together with the physical stack height is called the effective stack height. So the total effective stack height would be taken as sum of stack height plus whatever distance the plume is rising and then bending. Okay. So I think this has been shown here in this figure. Okay. The effective stack height would be sum of the height of the, can you see the pointer? Can you see the pointer now?
Yes, ma'am.
Yes,
Okay.
ma'am.
Yes, ma'am.
So that would be the sum of the height of the stack, this stack, and the height of the rise, plume rise, up to the vertical position. Okay. Then the plume will start bending. So H, if I say this height as a H plus HE will be effective height. Or other term can be used. The plume rise above the discharge point affect the downwind concentration at ground, right? So if the plume rise is high means, say we consider two cases where a chimney height is, say, only 100 meter from the ground level, and we are the just give an I will give an example of brick kiln. Say brick kiln where the chimney height is, say, 100 meter. Okay, and they are burning some biomass fuel which is like agricultural residue. Okay, so we and there is another thermal power plant which is burning coal. Okay, and the why these is my voice? Okay, Ashok, please mute your mic. Okay, so okay, so take two examples. One is for brick kiln, 100-meter height stack. Another is power plant, 200-meter height stack. The power plant is burning coal, which is high calorific value fuel, higher than the biomass. Biomass means agricultural residue, say any uh, rye or sarso or pulse residue or maybe rice husk or whatever. So this particular biomass will have low calorific value, high moisture content. Therefore, what will happen? The plume rise in case of brick kiln, where the combustion is poor, the stack height is maybe we can consider the same stack height, but because the combustion is poor, the moisture content of the flue gas is high. The exit velocity might be poor because there is no because of the heat content of the flue gas is lower compared to the heat content of the flue gas from the thermal power plant. So in that case, the plume from the brick kiln will rise at a lower height compared to power plant. So all these factor which are related to the even combustion process in combustion process, fuel type, etc. in the industry also affect the plume rise and therefore their downwind concentration at ground. So that is one thing. The other factor which will affect the downwind concentration would be meteorological parameter, right? So that which we will talk about that in the next slide. Higher the plume rise, greater distance is for diluting the contaminated gases as they expand and mix downward. So if the plume rise is high, then it will bend, but require a larger or you can say larger travel time for the gas to come down and touch the ground and increase the ground level concentration. So that is what the CPCB, Central Pollution Control Board, has recommended the height of the stack for power plants should be greater than 200 meter. So there are criteria for each kind of industry, that what would be the stack height for the industry depending upon the concentration of the pollutant and you can say risk from the pollutant, and also at like what is the distance of residential and commercial establishment uh, in the downwind direction from that source. Okay, so that criteria are there. If you are interested, you can go to the site, CPCB site, and you can find the whole manual, or you can say standard operating procedure, etc. for the industries. um, Downwind distance, atmospheric dispersion will also depend upon the downwind distance. Okay, so greater the distance between the point of discharge and the ground level receptor. What is receptor? Receptor means, say there is a commercial and residential establishment 100-meter away from 100 kilometer away from the stack. So that is the receptor site. So where the population is living, right? So a receptor downwind, in downwind direction, what is the distance of that receptor establishment, that is that also will decide like what should be the height of the stack, and what like how much you can say the capacity of that power plant or any industry, so that they will not discharge the pollutant exceeding the ambient air quality norms at the receptor side. Is that clear what I'm saying? Do you know what is ambient air quality norms? Do you know that? Anybody?
Have the NAQS?
Yes, yes. NAAQS. Yes, National Ambient Air Quality Standards. What are they?
They are levels of different components of the environment set up by different committees for a normal atmosphere.
So, ambient air quality standards are the norms given for various Criteria pollutants means the pollutants which can affect the human health. Okay. Uh, they are chosen based on their risk on human health, and their concentration threshold concentration has been have been defined based on the toxicological study, epidemiological study, and so on. So, for example, say there are five criteria pollutant: PM, particulate matter, PM 2.5, then CO, NOx, SO2, ozone, etc., and even the PB is included, lead. Okay. Now, from toxicological studies and epidemiological studies, the health risk of these pollutants are known up to certain extent, not fully understood, but up to certain extent we can say that the concentration above this will have a deteriorating effect on human health, or maybe it will cause the respiratory problem, maybe it will cause whatever. So based on that, they have defined the limit of this pollutant, and in two at two time different time period, like 24-hour average limit, sometime 8-hour average limit, because ozone, for example, ozone which is highly reactive, for ozone, the limit was defined for 8-hour average or something, and then for PM and all there are annual average limit also. So, example, for PM they say 24-hour average limit should not exceed 60 or 80 microgram per meter cube, while for annual average it should not exceed 40 microgram per meter cube. Okay, so these are the limit. What they are saying, below this limit everybody is safe, above this limit there would be health consequences. So that is the criteria in order to decide uh, if you are if you are proposing any industry in any region, then based on this criteria, the capacity of the industry, that how much production they can do, so that whatever the industry will emit will not violate the ambient air quality norm at the downwind receptor side. So that is one most important criteria in deciding the expansion of the city, development of industrial zone inside or outside the city, and so on. Okay, so downwind distance is very important. What is the distance of source from the receptor side, where the residential and commercial establishment is there, governs the whole dispersion related, you can say, calculation. Then wind speed and wind direction. So of course the wind speed and wind direction would be important. Wind speed, we know that there are three component of wind speed: horizontal, vertical, xyz, right? So and this three component will help the pollution which is coming out from any source to get diluted in the atmosphere. Okay, because of the high wind speed, there would be turbulence, and the dispersion and dilution before reaching to the receptor side will be high, and the concentration at the receptor side will be low. If the wind speed is low, or the atmosphere is stagnant, there is a calm condition, then what will happen? The pollution will not disperse quickly. It will remain in the atmosphere, and it will slowly travel in the atmosphere. Therefore, the concentration probably at the downwind side would be higher than the first case. So and wind direction, yes, when we propose any new industrial establishment, we have to see like the wind direction should be opposite to the receptor side, means the wind should take the pollution to the opposite side, not towards the receptor side. So that all these things should be taken into account, and some of these have been taken into account in dispersion modeling, and some we take into account during the planning of the source, any new development. Stability class. So we have already talked about the stability class. There are three classes: neutral, stable, and unstable. So we know that more unstable, that means more dispersion and dilution. That means low concentration of pollutant in the atmosphere. While for stable condition, it is just opposite to unstable condition. So this is what dispersion model actually takes into account. A dispersion model is a mathematical description of meteorological transport and dispersion process that is quantified in terms of source and meteorological parameter during the particular time. So basically, two major factors which go, or input data which go into the model, is source characteristics and meteorological parameter. And out of source characteristics, emission rate is one of the most important parameter, other than shape or size of the source, like stack height, stack diameter, all that goes. But emission rate should also be known to calculate the concentration in the downwind or upwind direction. The meteorological parameter required as input, including wind direction, wind speed, atmospheric stability. In some model, vertical mixing and lapse rate can also be included, right? Vertical mixing and lapse rate, the temperature lapse rate, we already learned about that. Stack physical height, diameter of the stack at discharge point, the exit gas temperature, velocity, mass emission rate. As I told you, mass emission rate is gram of pollutant emitted per second. Okay, that should also be known. Gaussian plume model, there are certain assumptions because the whole atmosphere is highly dynamic in nature. We cannot simulate all the characteristics of the atmosphere. So some assumptions are made to simplify the mathematical expression for dispersion model. For example, atmospheric stability. So stability classes have been defined. We will learn about that in next few slides. And it is assumed that atmospheric stability in the atmosphere is throughout same. It is not changing with respect to distance. So just one is atmospheric stability class would be considered at one time. Okay, so there is no change in atmospheric stability class with respect to time and distance. This is what it's saying. Turbulent diffusion. So turbulent diffusion is the random activity diffusion, you know, right? Diffusion is something which you learn even in first year of your BTech, and even in chemistry, right? Chemistry in 12th class. So diffusion is random activity, and hence the dilution of contaminated gas stream in both horizontal and vertical direction can be described by a normal Gaussian equation. So what does it mean? We know that atmosphere is highly turbulent when the wind speed is high, right? There is a turbulence in the atmosphere. Now, what it is assuming that the spread of pollution, or you can say dilution of the pollution in the atmosphere, follow a certain pattern. It's a distribution. The concentration distribution of pollutant follows a normal or Gaussian equation. Okay, normal distribution equation. Okay, this is what is assumed, which may or may not be true, but we don't have any other choice to simplify the equation. Effective height, the contaminated gas stream is released into the atmosphere at a distance above the ground, and we take actually the height is equal to physical height of the gas plus plume rise, which is the effective height of the plume. Diffusion. Okay, so this is something like it says this Gaussian plume model assumes that there is no diffusion in x direction. Okay, so whatever concentration change is only following the normal distribution is only y and z direction. Okay, diffusion is not there. There are other phenomena like transport of this pollution in x direction, but no diffusion. It's not because of the diffusion. When diffusion works, when there is a difference in concentration or temperature, right?
Yes, ma'am.
Diffusion means so diffusion means like traveling of pollutant from high concentration to low concentration zone, right? This is diffusion, mass diffusion. Anybody from chemical engineering? I know you know that. Anyone from chemical engineering? Okay, you don't want to answer. Okay, no reaction, no deposition. So what this particular assumption says that there is no reaction of pollutant like two pollutant, even the between the two pollutant there see we know that VOC and NOx react with each other and form O3, right? But that reaction pathway or sink means removal of the pollutant from the atmosphere, all that have not been taken into account in dispersion model equation development. So there is no reaction of the pollutant, there is no absorption or like removal of the pollutant when the pollutant strikes the ground. They come to the ground surface. So whatever is coming at the ground, it will be reflected back again in the atmosphere. This is what it assumes. So to just simplify the assumption. So this is how the plume looks like, and so I have already explained HS and HE. There I have to correct. It's means I want to use the same term. So HS is the stack height, HE is the effective height, which include the stack height plus plume rise. Then there is a this is x direction, y direction, and z direction. Wind is blowing in x direction. So see the center line of the plume is shown here, and the Gaussian distribution of concentration, pollutant concentration in y and z direction is, so this is z direction, this is y direction um, distribution. So yeah, so now this is the equation. I am not teaching you the derivation of this equation because it's very complicated. If you want, you can go through the derivation in one of the book, atmospheric dispersion book separately. I can upload the book. I have a soft copy of the book, but it's a little complicated to understand this Gaussian dispersion model equation derivation. So I'm not including that. So this is the equation where, hello, where the concentration is given by E, the emission rate, Sy and Sz are the, actually this can also be said as sigma y and sigma z, which are the coefficients in y and z direction, standard deviation or coefficient in y and z direction regarding the Gaussian distribution or normal distribution. U is the horizontal wind velocity, y is the distance in y direction, z is the distance in z direction where we want to determine the concentration. So it's a xyz coordinate, you can say. uh, H is the effective stack height. Sz, as I said, it's a standard deviation or the coefficient of Gaussian distribution for z direction. So uh, this is the formula, and what it's actually, what is it doing, the emission rate is a and it is multiplied by exponential uh, concentration change or concentration in y and z direction, where in the z direction z minus h is taken, and here z plus h. What is this z plus h? So we have the assumption where it says that when the plume strikes on the ground, it is not absorbed in the ground, but there is an imaginary source minus h distance down, you can say, below the ground, minus h distance below the ground, which is emitting the imaginary plume. So it's the overall, I can make it in one sentence that there is no sink for the pollutant. There is no sink for the pollutant in the atmosphere. Whatever is coming out, it is remaining in the atmosphere. So that's why there are two terms uh, for Z. Okay, Z minus H and Z plus H. So you can play with this equation. If you want to know the ground level concentration, that means Z is equal to 0 and Y is given, then at a certain Y distance, then Z, you just put the Z is equal to 0, you will simplify the equation as E emission rate divided by whatever this same term. 2 is cancelled out because you will have 2 into exponent of 1 by 2 minus h by sz square. So 2 will be cancelled out, and then this y term will remain as it is. Okay. Um, Ground level concentration at the center of the plume. That means the when z is 0 as well as y is 0, then the simple formula would be this one. Okay. The plume rise can be calculated by different formula. There are two formula are given. Oak Ridge formula I have listed here. There are one more type of formula from the other scientist. I will also list the same over here in the same slide. I have not done it. So plume rise can be calculated using the stack velocity, d the diameter of the stack, u is the horizontal wind speed, 1.5, 2.68, these are all constant. P is the pressure inside the in kilopascal. TS, TA, and R the temperature of stack or flue gas. temperature of flue gas in degree Kelvin. TA is the temperature of ambient temperature in degree Kelvin. The diameter, as I already told you. So so now the question is how to find out the SY and SZ. So as for SY and SZ, we need to know the stability class of the atmosphere. And here the table 3.1 listed the stability class for different wind speed at 10 meter per second, at 10-meter height. Okay, there is one formula. Using that you can calculate the wind speed, horizontal wind speed at any altitude, using the wind speed at 10-meter height. Okay, so I will also put that formula. I have not included in this because now it's an open book exam. You can have this slide during the exam, so I will just put that formula also over here. So the day and night like stability classes are given separately. uh, I will just explain in brief. During daytime, due to solar radiation or insolation, there is a possibility of higher turbulence in the atmosphere, therefore unstable condition to prevail. However, during the night time, as the temperature goes down and wind speed becomes like calm, there is not much turbulence in the atmosphere, so the stability class will basically, most of the time it's a stable condition, or sometimes it's a even inversion condition may prevail. So the value of SY and SZ can be calculated um, once you know the stability class, and then you can put the using the second table and noting down the information on various constant A, C, D, and F. You can use these two formula to calculate SY and SZ. However, there are two different graphs. One of them is here for horizontal. This is for SY or sigma Y, and at any downwind distance, knowing the stability class, you can just fetch the information on sigma Y using this graph. Okay. Similarly, for sigma Z also, if you know the downwind distance, you can just note down the information, and stability class, you can note down the information on sigma Z. So this is first example, and I what I will do, the solution is here. Okay. um, so I will just give you I think, yeah. So I will ask you to just note down sigma y, sigma z, and try to solve this question. Okay. What I will do, I will just put some of the questions, similar kind of question on MS Team. One document I will upload uh, to for the practice. Whenever you have time, and you can go through the exercise and solve the question. So this example is very simple. This is a coal power plant which is emitting SO2 in the atmosphere at the rate of 1656 gram per second. Uh, we need to know the concentration of center line SO2, center line concentration of SO2 at 3 kilometer downwind distance, while the atmospheric condition is overcast afternoon, and wind speed is 4.5 meter per second. So overcast afternoon and wind speed is 4.5 meter per second. From table 3.1, you have to first see for a given wind speed which is like between 3 to 5. It's a overcast afternoon, so it's not night, it's afternoon. We can say it's a uh, because it's a overcast, right? That means there are clouds in the atmosphere. Maybe we need to take C as a stability class. Let's see what this question has taken. In this question, stability class is given. Okay, so see here it is taking D. Now why D? 3 to 5 overcast afternoon. Yeah, I think no. This should be C, not D. See, it's a afternoon, no, it's not night. So somehow I might have selected the wrong.
Ma'am, in
Though
the below the table, the text is written.
what?
Just below the table.
Yeah. The neutral class D should be assumed for 1 minute. 1 minute. Okay, I am not able to. Mm, hmm. Assume for overcast condition during day and night. Yeah, that is one thing which is assumed, that all the overcast condition you can assume D as a stability class. However, if you see the table, you will find even C is okay. C is also okay. So if this is given, you can assume D for all the overcast conditions during day and night. Okay. So I don't think it will make like a significant change in your answer whether you consider C or D. Let's see. Maybe I can solve this example with C and D both, and then find out how much difference is there. So that's there. So you can say D is the class. You can determine SY and SZ, because for D class you can see what is the value of A, C, and D when the downwind distance is greater than 1 kilometer, because it says 3 kilometers, 44.5, 0.516, and minus 13. So that's why, and as said, A is common, so A is always 68. We can calculate SY and Z, or we can note down the information from the graph. Then if that is known, then you have you have the formula for when y is equal to 0 and z is equal to 0. Put everything in the formula and you will find out the concentration of SO2. So there are more examples in this slide. As I said, I will put some of the unsolved question uploaded on MS Team. You can go through the question and you can try to solve them. Okay. So then we will learn about the inversion loft, and there are more about the prune behavior and all in the next class. Okay, fine. Is there any question, or you think something is not clear? Just tell me. So I will prepare it for the next class and brief the same. Okay, see, your means if you have any like something which is not clear, then you can say. But this feedback actually gives me an idea, like the explanation is clear and enough or not. So just be honest. It's nothing to do with your you can say marks or evaluation, because I will not remember who said what. So if you have anything you think like it's not clear to you, I can explain it next time. Is there any question? So let me just see. Aditya Raj.
Yes, ma'am.
So you are here. Akash Lohia. Aladi Ajay. Aman Gupta. Okay. Is there any question? Ayush Purohit.
Yes, ma'am.
Ma'am, can you also upload some of the solved problems too?
Solve problems. Let me see if I can scan. So, have you find this book? Have you found this book, Davis and Cornwell? Have you found the book Davis and Cornwell?
No, ma'am.
How come? It's available, I think, on internet. I don't remember, but I think in last semester or maybe somebody informed me that it's available. So can I will show you the book. Can you show the book? Can you see the book now? So it's this kind of book. If you will find this book in even in like a second hand copy, it's a very good book. It's very good book. You can go through many examples in this book. So I will see, like, see, I have to scan the book, the solved and unsolved question. No, I don't have any TA here in the campus to do this for me. So let me see how much I can upload. I cannot promise that I will upload everything, but I will try to upload at least some unsolved question and maybe one or two solved questions. Fine.
Yes, ma'am.
Yes, ma'am.
Okay. Okay, so we will meet next week, Tuesday. Okay, so as I said, I would like to shift your class on Tuesday and Wednesday because sometime Friday is very busy. I have one meeting in the afternoon, some other meetings in the forenoon. So I want to keep and one more class on Friday. So I just want to keep that less loaded. Okay. Fine. So we will meet next week on Tuesday. Thank you. Bye.
Thank
Thank
you,
you,
ma'am.
ma'am.
किसी को कुछ पूछना है क्या? किसी ने हैंड रेस किया है शायद, राइट?
Friday is a holiday. Friday no class.
फ्राइडे मैं क्लास नहीं लूंगी ना, अभी 2 दिन ले लिया, बस 2 दिन से ज्यादा क्लास लेना मैं फ्राइडे वगैरह तभी लूंगी जब ऐसा होगा कि मुझे कुछ एक्स्ट्रा टॉपिक या टॉपिक पूरा नहीं हुआ है, कवर करना है, देन आई विल अनाउंस द फ्राइडे क्लास. So I will use that as an extra slot to complete the syllabus. Fine.
Okay.
Okay, so I am downloading the
Okay,
attendance
ma'am.
note. Okay, whoever is present is present. Let me stop the recording also.